Hey there. Subscribe to my channel. And also press this bell icon, so you never miss any new updates, cause whenever we upload new video you will get a notification on your phone.
Hi, today in my bench I have this Energizer. It is a small batteries charger. Now this charger came to me by a customer of mine that who got it brand new in its box from a friend of his as a gift. Now, as the owner explained and elaborate that he tried to use it in order so he can charge a set of AA batteries, but the charger was not able to charge them. So he replaced the batteries with a set of brand new AA batteries, and also the charger was not able to charge them at all. So he contacted me and asked me if I can take a look at it and see what's wrong in it. And as you can see, I already opened it and fixed it and did a few modification in it in order so he can work in the correct way. So today in this video I'm going to show you the quirks and the design that this model has, and also the modifications that I did in order so I can make this charger work in the correct way. So let's begin. So this is the charger main board, and if we take a look at it, we can see that it is a single-sided board and most of the parts are SMD and they are installed in this side. So yeah. Now there is two main circuit in this charger. There is the primary circuit and there is the secondary. Now the primary circuit, it is what connect directly to the main AC power grid, and it holds the chopper transformer driver circuit. Now in this charger or in this model they use an IC, and that is really good, but we can see that there is something it is missing from this circuit, and that is a photocoupler IC in order so this IC can monitor the output of the chopper transformer. Now in the secondary side there is the rectifier diode, and there is the microcontroller IC, and this is what controls the entire charging circuit. Now this charger it can charge 4 AA batteries in the same time, or 4 AAA batteries in the same time, and he charged them 2 at a time. So the charging circuit, it is divided by 2. So this is the first charging circuit and this is the second charging circuit, and these two batteries, they are connected in series, and these two batteries also are connected in series, and they are charged by this transistor. Now the charging circuitry, I really like it and I love the layout of it, but I found that there is a very two awful things about it. Now the first thing that I found it awful, that they use this small type SMD transistor as a charging control transistor. So yeah, and from the size of it we can see that it is very small and should be a lot more bigger than this. So yeah, and the traces, they are very small. The second thing that I don't like about this charger circuitry, that there is no charging LED for each separate charging circuit. There is only a one dual type LED, and this LED, it is what light in the charging process or in the charging process as red, and with the charging it is finished, it lights and it turns into a green. but it doesn't tell you if these two batteries if they are fully charged or not, or these two batteries they are fully charged or not. It only turn and light green when all of the batteries are fully charged, and that is really bad in my point of view. Because if these two batteries are fully charged and you are waiting for at least two set of batteries to be charged, you will have to wait until the all of the batteries are fully charged until you can use them. So yeah. So in order I could boost up the capabilities of this charger, I made some modifications in the circuit and in the component of it. Now the first modification, it is about the charging transistors, and as we can see, this little SMD transistor, it is what control the charging process for the both batteries. Now this is the SMD version of the SS8050. Now according to the datasheet of the SS8050, it can handle up to 1 amp at the maximum. But this SMD version, it has the capability of handling up to 500 milliamp at the max. So it is half of the original one. So yeah. So in order I could maintain the original one and increase the current capability of it, I made and designed this little PC board, and I installed three or four, as you can see, transistors that it has the same rating and the same number like this, and I'm going to connect each of these two transistors in parallel with this one. So in the end I will get 500 multiply with 3, I would get up to 1.5 amp at the maximum. So yeah, this is a lot more better than the original design. Now I tried to fit a bigger type of transistors, but actually there is no place for a bigger type of transistor to be installed. Now the suitable number to be installed and drive the charging current for any type of these batteries, it is the B774. This is a really good number, and it can handle a lot of current, up to 3 amp. So this is really good. But as you can see, there is no place. So in the end, what we will get, these two transistors are going to be connected in parallel with this one, and these two transistors are going to be connected with this one, and in the end we will have 1.5 amp at charging capability or current capability in each of these charging transistors. So yeah, that is the first modifications that I did. The second one, I minimize or lower the current limiting resistance in order so I can boost the charging current of the charging circuit for these two battery packs. And I done this by adding this little resistor in parallel. So yeah. Now the third modification that I did was designing and installing a full charge indicator or sensor circuit, and I'm going to connect it into the positive of the battery terminals. As we saw earlier, and as I told you, this charger, how it works, it charges two batteries at the same time, and it connect them in series. So yeah, so whenever these two batteries, for instance, they got done charging, the LED or the indicator will indicate the user that these two batteries are fully charged and he can use them. So yeah. In this way, he will not have to wait until the green LED or the dual LED to light up or turn green. So yeah. So what I'm going to do now, I'm going to reinstall all of these modification, solder all of the component into their places, and we will see how this charger will perform. So here's the charger has been completely reassembled, and I install all of the modifications that I told you about in it. And now I'm going to connect it with power, and we will see how the charger will behave. So here is the charger has been plugged in to the AC grid, and here is some batteries that I already charged them with a different charger, so I know they are fully charged, and I'm going to install them into their socket, and we will see how the charger will behave with a full charged batteries. So yeah. So here's two batteries has been installed into their charging compartment, and these two batteries, they have a welded solder tabs. So they have tabs, you can solder them to a wire or to a PCB. So yeah, but regardless of this variation and the type of the batteries, these are still a 1.2 volts batteries, regular type, and they will charge as a normal type batteries. Now, from the other hand, we have these two Sony batteries. They are old, but they are still good, and they will charge also as a normal type batteries. So let me just install them into their charging compartment, and once I install this one, we can see that the red LED has been lit up, and this will indicate if there is a battery and it is charging. So yeah. Now after a while, this green LED will light up once these two batteries are fully charged, and the same thing will happen once these two batteries are fully charged. So let me install the other one, and we will see how the charger will behave. So once I installed it, we can see that the two LEDs has been light up. So this indicate that these two batteries are now fully charged and they are ready to be used. So yeah. So I believe the modifications that I did to this charger are working really well, and this charger, it is now ready to be delivered to the customer. So I hope you enjoyed this video. If you did, please like, subscribe. Thank you for watching. See you next time.